Hi everyone, tonight's video is going to be about midpoints. So, the midpoint of a line segment is the point that divides the segment into two congruent segments. So in other words, it's right in the middle. So if I have a line segment AB here, and I have point M right in the middle, such that AM is congruent to MB, then M is the midpoint. Okay, so it's usually just right in the middle between the two endpoints. That's the definition of midpoint. Pretty straightforward. So, to find the midpoint of a segment, given the endpoints, we have something called the midpoint formula. So it usually goes hand in hand with the distance formula, which we talked about yesterday. And that is that M, usually the capital letter we use for the midpoint, is an ordered pair that consists of x sub 1 plus x sub 2 over 2, comma, y sub 1 plus y sub 2 over 2, where x1, y1 is the ordered pair of one endpoint, and x sub 2, y sub 2 is the other ordered pair of the other endpoint, I should say. Or in other words, are the endpoints. Okay? So all we'll be doing, again, similar to what we did with the distance formula, is just plugging in for values of x1, y1, and x2, y2. So let's do an example, and we'll say find the midpoint of, let's have 2 points here. Let's say 5, 12, and -4 and 8. Okay, those will be my 2 points. And just like I did with the distance formula, I want to get in the habit of writing out the midpoint formula every time I use it. So here we have M is x sub 1 plus x sub 2 all over 2, comma, y sub 1 plus y sub 2 all over 2. Okay, and so now I want to figure out what x sub 1 and y sub 1 are, and x sub 2 and y sub 2 are, and I'm going to plug them in. So here we go. X sub 1 is 5 plus x sub 2, which is -4 all over 2. And y sub 1 is 12 plus y sub 2, which is 8 all over 2. So the midpoint is 5 plus 4, or 5 plus -4, which is 1 half, comma, 12 plus 8, that's 20 over 2. You can simplify that. So our midpoint is 1/2, comma, 10. So that is the point that is right between, or right in the middle on the same line, collinear with 5, 12 and -4, 8. Okay, so that's just simple. We're just going to be using the midpoint formula. We're plugging in numbers to find the midpoint. Another thing that we'll think of when we're using the midpoint is we'll be using some algebra, right? So we'll have some examples where we're going to use algebra to find the different measures. So let's do an example of that. Let's say we have the line here, x, y, and z. And let's say that the distance between x, y is 2x plus 3, and the distance between y and z is 6 minus 4x. And then I'll also say that y is the midpoint of xz. Okay, so with that knowledge, is that y is the midpoint of xz, that tells me that xy is congruent to yz by definition of a midpoint, and therefore, since those two segments are congruent, that means they have the same measure. So I can also say that 2x plus 3 equals 6 minus 4x. So now what I want to do is find the measure of xz. Right? So I want to find the measure of xz. Remember, we've mentioned that when you say the measure of a line segment, you don't need to draw the little line above. Okay, so if I want to find the measure of that, but I don't have any numbers, I have variables here. I don't have the distance per se. I can use my algebra skills to figure that out. So what we want to do is find the value of x that we can plug in here and then determine the two values of these two separate segments and then add them together to find the whole total of xz. So let's plug in and solve for x. So first thing I want to do is get x isolated or on the same side. So I'm going to add 4x to each side. And so over here I have 6x plus 3 equals 6. And so now I'm going to subtract 3 from each side. Subtract 3. And so now I have 6x equals 3. To isolate x, I'm going to divide both sides by 6. And so now I have that x equals 1/2. Okay, so that's the value of x. It doesn't really tell me the value or the measure of xz yet. I have to plug that in for each part. So xz is the total length of this line segment here. So I know that it's comprised of 2x plus 3 plus 6 minus 4x. So now I know what x is. I can plug in for that. I can say 2 times 1/2 plus 3 plus 6 minus 4 times 1/2. So 2 times 1/2, that's 1. So I have 1 plus 3 plus 6 minus 4 times 1/2, which is 2. So minus 2. So 1 plus 3, that's 4, plus 6 is 10. 10 minus 2 equals 8. So that's the total distance of xc. So the measure of xc equals 8 units. Okay, so that's another thing that we will do using the midpoint formula. That definition telling us that when y is the midpoint, it divides these two separate segments, xy and yz, into two congruent segments. So those two lengths are equal, and I can solve for x and then determine the other information. It may ask me, what's the distance of xy? So again, I would solve for x and then plug in for here and evaluate for xy or yz, or like we did in this case, xc. Last thing we're going to do is another construction. We talked about constructing two congruent segments the other day. Now we're going to talk about constructing a bisector. And a segment bisector is any segment, line, or plane that intersects another segment at its midpoint. So if I have this segment here, let's call it AB, and I want to find a line or line segment that will intersect AB at its midpoint. So this is another construction, like we said, where constructions are all about using tools that don't necessarily have measurements to find a specific measurement. So in this case, I can't measure out halfway between A and B, right? But I can use a compass to figure that out for me. So what we're going to do here is, with the compass, we're going to draw an arc. Let's see if I can move this up and down without drawing a whole entire arc. Here we go. So I'm going to put one point of the compass on one of my endpoints, A. And I'm going to open it up so that it was more than halfway between A and B. That's the only way that I can get this to work, is it has to be a little bit more than halfway. So I'm going to draw a little arc up here. And then I'm going to swing it down below the line. Let's move this a little bit more. And draw another arc down there. Now I'm going to flip this around. I'm going to drag it over, and I'm going to put the other point of my compass on the other end, point B. And I'm going to draw an arc up here. And then I'm going to move it down and draw another arc down here. And what you'll notice, hopefully, is that these two arcs have intersected. And so now we'll get this out of the way. These two arcs above have intersected. These two arcs below have intersected. And what I can do now is draw a line connecting the two of them. And that line is going to intersect AB precisely at its midpoint. So I constructed the midpoint of AB, we'll call it M, by taking my compass, put one end on A, open it up more than halfway, draw an arc, and then above and below the line, and then do the same thing from putting the compass on point B and drawing an arc above and below and then connecting the two. Then that I know intersects AB right at its midpoint and is therefore the bisector. So that's another construction that we can do with just a simple compass, a simple tool. And we'll do some more examples with that in class tomorrow. And hope you have a great night.